Welcome back to Stat 251, Essential of Statistics. This is the lecture for Chapter 2. Let's get started. In Chapter 2, we'll explore some important characteristics of data, including the center of a data set, variation in the data, how the data are distributed, outliers we might have in a data set, and changes in these characteristics over a period of time. We will also explore some tools that we can use to help us gain insight into our data. These tools, we can use these tools to organize and summarize our data in such a way that it'll help us to see important characteristics about our data. The key concept of this section is when working with large data sets, a frequency distribution or a frequency table is often helpful in organizing and summarizing data. A frequency distribution helps us to understand the nature of the distribution of our data set. A frequency tells you how often something has happened. The frequency of an observation tells you the number of times the observation occurs in the data. Frequency tables show you how data are partitioned among several categories or classes. And those classes can show either categorical variables, sometimes called qualitative variables, or they can show quantitative variables, sometimes called numeric variables. Recall, you can think of categorical variables as categories such as eye color, brand of dog food, and quantitative variables such as numbers. Let's consider this example. Here we have a list of numbers that display the number of devices in a sample of households. In this example, the frequency of households with 9 devices is 5. That's because if we go through and count the number of 9s in our list, we see 5 occurrences of 9. We can put these data into a frequency table like we see on the bottom right. Before we get started with frequency distributions, let's review some terms we will be using in this section of Chapter 2. Class limits, or boundaries, are the numbers used to separate classes. Each class will have a lower limit and an upper limit. And these are the lowest and highest numbers in each class. The lower class limits are the smaller numbers that belong to each of the different classes. So in Table 2-2, the lower class limits are 75, 125, 175, 225, and 275. The upper class limits are the largest numbers that can belong to each of the different classes. And in this table 2.2, our upper class limits are 124, 174, 224, 274, and 324. Class boundaries are the numbers that we use to separate the classes so that there will be no gaps that are created by class limits. Let's look at Figure 2-1. You can see that there are gaps that are created by the class limits that we saw from the previous example 2-2. In this figure, we see that the value of 124.5 is the center value between the class limit of 75 to 124 and the other class limit 125 to 174. Our lowest class boundary in this example is 74.5 and our highest boundary is 324.5. Class midpoints are the values in the middle of each class. Each class midpoint can be found by adding the lower class limit to the upper class limit and then dividing that sum by 2. So if we go back to our table 2-2, we can calculate the midpoint for each of the classes by doing that simple calculation. So let's start with 74 to 124 class. We add 74 to 124 and then we divide by 2. That gives us a midpoint of 99.5. And then we would do that calculation for each of the remaining classes until we have all of our class midpoints. A class width is the difference between two consecutive lower class limits in a frequency distribution. To calculate the class width in this example, we simply take the difference from one of the lower class limits from the next lower class limit. And so in this case, we would subtract 75 from 125. That will give us a class width of 50. And then we would calculate that class width for the remaining classes. In creating a frequency distribution, there's 6 steps we want to follow. Step 1 is selecting the number of classes. There are no hard and fast rules about how many classes to pick, but there are a couple of general guidelines to follow. The first general guideline is we want to pick between 5 and 20 classes or 5 and 20 categories. And then the second guideline is to make sure you have a few items in every category. The second step is to calculate the class width. We do this by subtracting the smallest value in our data set from the largest value in our data set. Next, you divide that difference by the number of classes you chose. And finally, you will round this result to a whole number, and we usually round up. In step 3, we choose the value of the first lower class limit by either selecting the smallest value in our data set or a value that makes the most sense to us. Step 4, we use our first lower class limit and the class width to find the other lower class limits. So recall from our example of table 2-2, the lunchtime service of McDonald's, our first lower class limit was 75 seconds. So by simply adding our class width of 50 to 75, we get our second lower class limit. So 75 plus 50 equals to 125. The fifth step is we list our lower class limits in a vertical column, and then we use this information to determine the upper class limit for each class. So if the lower class limit of class 1 in our McDonald's example is 75 and the lower class limit of class 2 is 125, then it makes sense that our upper class limit of class 1 would be 124. Step 6, and the final step, is to put a tally mark for each observation into the appropriate class and then add all of the tallies in each class to get the frequency for each class. So using our McDonald's data set, let's create a frequency distribution. These data represent the speed of drive-through time service in seconds during a given lunchtime service. We have 50 observed service times. Let's start with step 1. For this example, let's just select 5 as the number of classes we will have for our frequencies distribution. Step 2 is we want to calculate our class width. So first we can find our smallest value and our largest value if we order our data. So here I've taken our original data set and I've put them in order from largest to smallest. This is easy to accomplish if you have your data entered into a tool like an Excel spreadsheet. And so you can see that our lowest value in our data set is 83 and our largest value is 308. So our class width will be approximately 308 minus 83 divided by 5, which is equal to 45, but we're going to round it up to 50 because that's a more convenient number for creating our classes with. For step 3, we will choose our first lower class limit. We can either choose our smallest value or a value that makes more sense to us. Our lowest number in our data set is 83, but this is not a very convenient number to work with, so let's round that down to 75. So 75 will be our lowest class limit. For step 4, we will add our class width to get the second lower class limit. And so we will add 50 to 75. So our second lowest class limit is 125. And then we will add 50 to 125 and get our third lower class limit of 175, and so on. In step 5, we'll list our lower class limits vertically, and then from this list we can identify the corresponding upper class limit. For the first upper class limit, we want to take the value of the second lower class limit and subtract the value of 1 because we want to make sure there are no whole number gaps in the classes, or between the classes, since we're counting seconds. So our first upper class limit would be 125 minus 1 equals to 124. So our first class is 75 seconds to 124 seconds. Now to get our second upper class limit, we start with our third lower class limit, which is 175, and we subtract 1 from 175, and that gives us 174. The 174 is our second upper class limit, and we continue this process for all of the classes. And for our last upper class limit, since we don't have a sixth class for this example, we would go ahead and calculate what that class would be if we were to have a sixth class. So our sixth class lower class limit would be 275 plus 50 equals to 325. And so our fifth upper class limit would be 325 minus 1, which is 324. So for this example, our 5 classes are 74 seconds to 124 seconds, 125 seconds to 174 seconds, 175 seconds to 224 seconds, 225 seconds to 274 seconds, and 275 seconds to 324 seconds. Finally, in step 6, we create a tally mark for each observation that falls into the corresponding class. So for our example, you can see that in the first class we have 11 observations that fall between 75 seconds and 124 seconds. Then we have 24 observations that fall between 125 seconds and 174 seconds, and so on and so on. A relative frequency distribution or a percentage frequency distribution is a different type of frequency distribution. With a relative frequency distribution, we aren't interested in the counts of each class, but instead we're interested in the percentage of observations in each class. And so each class frequency is replaced by a relative frequency or a percentage. A relative frequency distribution is calculated by dividing the frequency of a class by the sum of all frequencies. We can convert the proportion to a percentage by simply multiplying the proportion by 100%. And when you've finished, you want to sum up all of the relative frequencies across all of your classes, and that sum should equal to 100%, or it should be very close to 100%. In our distribution table of our McDonald's example, we'll replace the frequency with the relative frequency or with a percentage. And the sum of those percentages in the relative frequency distribution should equal to 100% or very close to 100% if we have any rounding error. So with our McDonald's example, we can calculate the relative frequency for the class 75 to 124 by dividing 11 by 50, because in this example we have 50 total observations. Then we take that number and multiply it by 100, and that gives us 22%. So in our first class, 22% of our observations were between 75 seconds and 124 seconds. 48% of our observations were between 125 seconds and 174 seconds, and so on and so on. A cumulative frequency distribution is another type of frequency distribution. Technically, a cumulative frequency distribution is the sum of one class and all of the classes previous to that class in the frequency distribution. All that means is you're adding up a value and all of the values that came before it. Note that in addition to using cumulative frequencies, the class limits may be replaced by using the expression less than that describes the new range of values. But often you will see that the cumulative frequency distribution, most people will just use the same classes that they used in the original frequency distribution. So for our McDonald's example, our first class would be all observations that are less than 125 seconds. There were 11, so our cumulative frequency for that one is just 11. For our next class, it's all observations that were less than 175 seconds. This would also include the first class because 125 is less than 175, and so we take the 24 observations and we add the previous 11. So our cumulative frequency is 35. 11 plus 24 is 35. And then our third class, we take our 10 observations and we add our previous 24 observations and our previous 11 observations, so that gives us 45, and so on until our last class, our cumulative frequency is 50. And remember, we had 50 observations for this example. Recall that we discussed previously that a frequency distribution can help us understand the distribution of a data set. It helps us to see the shape of the spread of the data over a range of values. Often researchers will look to see if the distribution or the data set has a bell-shaped curve. A bell-shaped distribution is said to have a normal distribution. The frequencies of a normal distribution start low and then they increase to one or two high frequency points, and then they decrease to low frequencies again. The distribution is approximately symmetrical, and the frequencies preceding the maximum frequency should roughly mirror the image of those following the maximum frequency. In Table 2-6, this is an example of a frequency of a distribution that satisfies those two conditions. The frequencies start low with 2 and 8, and then they increase to a maximum of 30, a frequency of 30, and then they decrease to a low frequency again. There is also symmetry to this distribution. That is to say that the frequencies of 2 and 8 that precede the maximum of 30 are the mirror images of the frequencies that follow the maximum of 30. The presence of gaps in the data set can suggest that the data might come from 2 or more populations. However, the opposite is not true. If your data set does come from two different populations, you may not necessarily find any gaps in the data. For example, let's look at the frequency distribution of the weight of randomly selected pennies. The table below reveals a large gap between the lightest pennies and the heaviest pennies. This gap suggests that pennies may come from two different populations. As it turns out, pennies minted before 1983 are 95% copper and 5% zinc, while pennies minted after 1983 are 2.5% copper and 97.5% zinc. This would explain the large gap between the lightest pennies and the heaviest pennies. They come from two different populations, one population being those pennies minted before 1983, and the other population of pennies that were minted after 1983 with a different combination of copper and zinc. Combining two or more relative frequency distributions in one or more tables makes comparison of data much easier. Let's look at a comparison of McDonald's and Dunkin' Donuts drive-through lunch services. This table shows the relative frequency distribution for the drive-through lunch service times for both McDonald's and Dunkin' Donuts. Because of the dramatic differences in their menus, we might expect the service times to be very different. McDonald's is known for their hamburgers, and the hamburger is a more common lunchtime choice, while McDonald's is better known for their donuts, and donuts are typically not considered a lunchtime option. By comparing their relative frequencies, we see that there are indeed major differences. The most obvious difference is that Dunkin' Donuts service times appear to be faster than those of McDonald's. That's it for Chapter 2, Section 1. Please move on to Chapter 2, Section 2, Histograms.